Now this CV by 3 will be the final charge. There were two questions, these two, Q and I through the 3R resistor. At time t. We have found Q at time t. Let's find out I at 3R, I in 3R at time t. This is I dash at time t, and we want I minus I dash. Look at this step, V equal to 9IR minus 3 times I dash R. I dash we have already found. That means I should not be a problem. So can you find I, and therefore I minus I dash. Or perhaps a smarter move would be to consider the right side loop Kirchhoff and apply Kirchhoff's law. And that way you will get it, I think, probably much more quickly. Right side loop, apply Kirchhoff's law. So you should get I minus I dash straight away in terms of I dash. And I dash you already know. I have written the answer for that current. See if you are getting it. And if you need help with that, raise your hand and I will do it quickly. I3R. Well, I will have to move on. So if you have any problem, let me know, or I'm moving on. Now, this is the systematic method to find Q. And if you find a problem where things are different from the standard discussion, you can go by this type of approach. However, I should tell you one short method also. There is a short method to find the time constant in such a case. And that goes like this. Watch from capacitor's point of view and make battery a straight wire. Make battery a straight wire. So that means that this battery will be replaced by a straight wire. Watch from the point of view of this capacitor. Look at the total resistance in the circuit. And what you find after that, 6R, this is straight wire, and 3R are in parallel. 6R and 3R in parallel means 6R into 3R upon 6R plus 3R. That is 18R square upon 9R, which is 2R, right? And this 2R is in series with this R, and that makes it 3R. This is a short method to find the time constant for not so straight cases. So once you know the time constant, and finding the maximum charge, I think, is very easy, because when the charge is maximum, capacitor becomes an open circuit. No current flows through this. So 6 and 3 are in series, 9. And voltage across 3R would be 1/3, V by 3. V by 3 will come across this capacitor because this resistor will create no drop. V by 3, that means maximum charge is going to be CV by 3 is going to be the maximum charge. Now that saves time because you can write your final answer immediately. CV by 3, 1 minus e to the power minus t by tau. This effective resistance is 3R. So time constant will be 3R times C. Done. So you are saved from writing all those equations and then solving them. So not that you don't have to know that. You have to know that. But in some problems, this can save some time. Any questions about this? Let me know. Consider this problem. It came in 98. The capacitor is not charged initially, and at t equal to 0 the switch is closed. Capacitor was not charged initially. Then what is the charge at some time t? What is the current through the middle resistor at time t? Well, looks like similar type of problem that we discussed. I think we discussed possibly a more difficult one. Now, here let's try the short method. Find Q at time t. So, what would be the Q at infinity time? Yes, any answer? Let's see. Infinity time means capacitor becomes open circuit. Cut it. And two series resistors, so each will eat half voltage, V by 2, V by 2. So across it will be V by 2. And this resistor will not create any drop because no current is flowing here. V by 2 will come across this. CD by 2. I hope you are following. If you have any questions, then let me know about Q infinity. Now, one more question. By following the method that I told you, can you tell me the value of time constant? (3RC by 2). Let me check. So, see, from this capacitor's perspective, short this battery. It's a straight wire. This R parallel, R by 2. And then this R in series plus R. That is 3R by 2. So, tau would be 3R by 2 into CS. You're right. 3RC by 2. So, the final answer is going to be Q equal to CV by 2 then T by tau. CRC by 2. What about the answer for the current? The question is current through the middle resistor. And I think I will leave it as an assignment question. And that you have to tell at time t. Okay? We stop at this point.